Hey. Welcome to our video. This is Wesley and Clark, and we are going to go through the problems. And I'll start. So number one on A, our null hypothesis is that the green cotyledons and constricted pods are going to be the two dominant alleles. And we also recognize that there can be differences according to sampling size and errors. We calculated the chi-squared results here. Let's see for number one. And for the chi-squared number, we got 43.72, and that was definitely in the dark green area. And so for C, we are rejecting the null hypothesis, and we propose for a new hypothesis that green cotyledons are still dominant, but now we propose maybe inflated pods are also dominant. We didn't really think so. Just see whether or not somebody's watching this video. And we're on number two.
Okay, number two was all about these weird mice that responsible people shouldn't be breeding. And so, so I asked about the coat pigmentation, and some are black, some are white, and then they get the heterozygous, then they're black and white spotted, and we know that that's codominance. Then for B, it wants the phenotypes and phenotypes. So just another big old Punnett square we drew out. Got all our info right there next to it. So we got for the genotypes that we've got big B, little b, then X with a big S, and then X with a little s. And then we also have one that's big B, little b, X with a big S, and then Y. And then for the phenotypes on that, all are black and white spotted and are normal, they're not shakers. And then on C, we had to do this chi-squared stuff. So there's lots. It's all of this. So we drew it all out, figured out the ratios. We had 6 different types, and so that we got that our, what is that number called? Our chi-square value as 4.768. And for D, because of that, we said that we failed to reject our null hypothesis because 4.768 is less than 11.070, which is the value that said we had to reject it at.
Sweet. For number three, oh, you got it right there. For number three, A, what is the probability that the first 5 offspring have small grins and can disappear? This is what we did right here. 5 in a row will happen like that. For B, it's what's the probability if you have 8 offspring, if 5 have large grins and can disappear, and 3 have small grins and cannot disappear. And this one we use a binomial formula, and that's that one right there. And we got 7.7 times 10 to the negative 4th. C was just the simple sum rule, because it's just the probability that you could have one individual be either a small grin and can disappear or a small grin and cannot disappear. So that was just 3/16 plus 1/16 is 4/16. And for D, it was another binomial one. It's 8 offspring, and then 4 have large grins and can disappear, and 4 have small grins and cannot disappear. So that was the same thing. You redo the equation again. As long as that's number 3.
4, not a whole lot of work for. It's right here. Mostly it was just looking at the pedigrees. Yeah, that's the word. And then going back and forth on the definitions and seeing what parts actually linked up. So for A, we got that it's autosomal because no generations skip inheritance, and then a father was seen to pass it on to his son and to his daughter. For B, we put that as Y-linked inheritance because only males were affected in this one. On C, we said it was autosomal recessive because there were 2 unaffected individuals that produced affected offspring. and it also goes from a father to a son and a daughter. D we put as X-linked recessive because it skips a generation, and carrier females produce about a 50% amount of affected sons. And then E we put as autosomal recessive because both males and females are affected, and you can see that it's recessive because it skips a generation.
Nice. And then number 5, it's just pretty much from the book. For 5A, we got some probability rule, and for the second answer is chi-squared test cross. For B, it was X-linked recessive and X-linked dominant in those 2 spaces. C was the sum rule. D was the independent events. E was autosomal recessive and Y-linked inheritance for the second space. The sampling size, when it's high, the sampling error is typically low. And for G, the degrees of freedom equal the number of phenotypic classes minus 1. So that's all our work for the group problems.